So, you ready for some more fun with limits? I think everybody's excited about limits. I sure am. Hey, what the heck? So what we've done so far with limits is we've looked at some visual ways to look at limits, graphs, and tables. We've talked about direct substitution and finding a limit that way. Also some properties of limits. But what if, and that's kind of our question for today, what if you do direct substitution and it's undefined? Okay, the function is literally undefined and you have no way to figure it out, and you don't have a graphing calculator and you don't have the graph of it. So what do you do? Okay, well, there are three methods that you can use to find the limit of something that is undefined. So I'm going to start in this video with the first one. So we'll start off with our question. What if you do direct substitution and it's undefined? So let me present my screen now so you can see it. And if you need some time, again, just stop the video and write down the question. Be sure to put the date. And what I'd like to do is I'd like to kind of take you through how are we going to find limits using some what we would call algebra techniques. So the first one is factoring. So what I'm going to do is I'm going to show you two problems. And these two problems are going to kind of review two of the major factoring things that we have to do. So let's look at the first one. What if I give you this function? I say f of x equals x squared minus 16 over x minus 4. Okay? And I'm going to ask you, we want to find the limit as x approaches 4 of that function. Okay, so we are looking for what this limit is. Now, in the previous video, I told you the first thing you should always do is do direct substitution. So let's see what happens when we do direct substitution. So I'm going to plug in the value 4 in for all of the x's. So I'm going to do 4 squared minus 16 over 4 minus 4. And lo and behold, what we get is 0 over 0. Now, in calculus, this is what we have a very special name for this function, okay, or this result. This result, 0 over 0, is not equal to 1. So please do not say 0 over 0, the limit is 1. What we call this is the indeterminate form. What that means is if it is the indeterminate form, it means that you can do some other things to find the limit. So let's do a quick review of how we would factor this thing out. So let's start with our original function. The original function was x minus 16 over x minus 4. So you should recognize kind of very quickly that this is factorable. Okay? Now, I want to remind you with this problem of the way that you factor this. This is a very common thing we'll see in on the AP test. This is the difference of perfect squares. So we need to remember a fast way to factor that. So if we have x squared minus 16, remember when you factor this, the quick way to factor that is to know what the square root of both of those things are. If you take the square root of x squared, that means this splits up into x and x right here. Now, what about the 16? Well, the square root of 16 is 4. It's 4 and 4. So what you have is x and 4. Now remember, when you do the difference of perfect squares, one of them's a plus and one of them's a minus. What I'm doing is I just want you to remember that shortcut. I'm not going to go through the process of why that works. You just need to remember how to factor the difference of perfect squares. So watch what happens now when I change the numerator to these two things, okay? And the bottom is still x minus 4. When you have the indeterminate form, and we factor the numerator using the difference of perfect squares, the thing that caused the problem cancels out, okay? So we have an x minus 4 on the top, and we have an x minus 4 on the bottom. And when those kind of quote-unquote cancel out or become 1, we now have this as our function. So now, what if I asked you to find the limit as x approaches 4 of this reduced function? Okay, so what if I asked you to find the limit as x approaches 4 of the reduced function with the x minus 4's reduced out or canceled out? Well, do direct substitution now. So what you have is 4 plus 4. So my limit is 8. This is my final answer. What factoring allows us to do is factoring allows us to remove the part that makes the numerator 0 and remove the part that makes the denominator 0. And then we can find the limit at that spot. Okay? So I want to show you another example. Okay? This other example is going to be have a little more complicated sort of fractions or factoring. So let's take a look at problem number 2. Problem number 2 is going to look like this, and we're going to find the limit as x approaches -1 of this function, 2x squared minus x minus 3, and then x plus 1. So the first thing you always have to do is you do need to do direct substitution. Now, I don't recommend that you always write it out. It's just going to take too much time. But you do need to figure out very quickly if it's 0 over 0. So I am going to write it all out so you can see it, but I am not requiring you to do this all the time. If you can quickly figure out that it's 0 over 0, you can just move on. Okay? So let's kind of do the math in our head. We have -1 squared, which is 1, times 2 is 2. -1 and -1 is a plus 1, and then minus 3. So of course, the numerator is 0. And then the bottom is -1 plus 1, which is 0. So yes, we get the indeterminate form when we substitute -1 in, and it does not exist. So here's what you have to do. We need to take this problem and we need to work with this part, -x squared minus 3. We need to factor this. Okay? You need to now take the time to factor that. Now, I'm going to show you kind of the fast way that you go about doing that. And because with the AP test, time is a factor, you have to factor kind of quickly. So the first thing we're going to do is we're simply going to look at the first term, and they are usually not going to give you really big numbers in that first term. So you just need to realize what are the factors of 2x squared that you can split it up into. Clearly, one of them can be 2x, and the other one is 1x. So 2x times 1x gives me 2x squared. Very important that you just quickly figure that out. Now, the second thing, though, is what we do with this -3, okay? The factors of -3 need to be placed here and here. So you have to try some things, and I suggest that you just do trial and error. So what numbers multiply together to give us -3? Well, -3 and 1, and then 1 and -3. So let's plug them into spaces. So let's do this. Let's do -3 and 1. So we're going to do -3 and +1. Now, what you have to check is you have to check what happens when you multiply this times this times this, and then you have to add them together. So -3 times 1x is -3x. 2 times 1 is 2x. And when I add them up, I get -x. If this and this are equal, you have found your factors. Okay? So our factors for the numerator are going to be, and I'm going to write it over here, 2x minus 3 over x plus 1. Don't forget that we have the bottom of the fraction. If you factor it correctly, this is one thing you should remember. If you factor it correctly, you should have a term that cancels out. Okay? So what this is going to do is this is going to make now finding the limit a little bit easier. If you factor it right, you should have a set of terms that cancel out. Now, finding the limit is going to be much easier because we're still going to find the limit as x approaches -1, but the function is now 2x minus 3. So if the function is 2x minus 3, we again go back to this direct substitution thing, and we are going to get 2 times -1 minus 3, and 2 times -1 is -2, minus 3 is -5. So the limit as x approaches -1 for this function is -5. Now, that's going to be the end of this video. It's just showing you how a review of how to factor and what you do in order to figure out the limit once you've done that factoring. Okay, so the next video will go on to the next one, and the next one that we are going to take a look at is something called rationalization. So hope you found this helpful, and I will see you in the next video.